In this video, we'll be looking at the normal distribution and central limit theorem tool. And specifically, we're going to be comparing the probability calculation to a standard error of the mean calculation probability problem. So let's get started. So for the first problem, we'll be looking at a population of values that has a normal distribution with mu equals 60.9, that's the population mean, and the sigma, population standard deviation, of 73.6. You intend to draw a random sample of size n equals 22. Now, the first question says, find the probability that a single randomly selected value is less than 10.7. Now, this is actually a bit of a basic problem compared to a sampling distribution problem because we're looking at just a single value. So this is just going to be a probability calculation and nothing else. So we will just enter in the mean of 60.9, the standard deviation of 73.6, and notice that we want to find the probability that it is less than 10.7. So if we want to find the probability of less than 10.7, that is an area to the left. That's this first tool under the probability calculations. So we'll enter in the green cell 10.7. And there's our probability. Okay, now looking at the second problem, we have find the probability that a sample of size n equals 22 is randomly selected with a mean less than 10.7. So notice the first problem is just looking at a single randomly selected value that is less than 10.7. And in the second problem, we're looking at a sample size, not of a single value, a sample size of n equals 22. And from that sample size of 22, we want to know the probability that we're going to have a mean, a sample mean, because it's a sample size of 22. So what's the probability that we'll have a sample mean less than 10.7? Notice it's still less than 10.7 for both these problems. But in the second problem, we're looking at a sample size of n equals 22. So this is a sampling distribution problem. So that brings us down here to standard error. We need to know the standard error of our sampling distribution, the sampling distribution of x bars, of sample means. Okay, so the idea is the only way we can find a probability of anything involving a mean, a sample mean, we must find the distribution of sample means. So we're going to enter in the standard deviation. The standard deviation is 73.6, and the sample size is 22. And that gives us a standard error of 15.69. Now, that's just the standard error. And you may remember that the mean of the sample means, mu sub x bar, because we need the mean of the sample means and the standard deviation of the sample means, or standard error. So now we have both, because we know that the mean of the sample means is equal to the population mean. Okay, so we are going to enter in, we're going to keep the mean there because it's still the same, because mu sub x bar is equal to mu. But standard deviation is going to be our standard error now, because we want to find the probability of a sample mean being something less than 10.7. So we need the standard error in here now. So we'll just enter 15, actually we can go ahead and do this, equals, and we can put in this, 15 point, that cell right there. So I'll go up and I've just entered in the standard error in here. And notice that we still want the probability of being less than 10.7, and our probability has now changed. Noticed it was, and I'll hit Control Z right now to undo it, and you'll see the probability will change. So it goes from 24.76% to, I'll redo, less than 0.1%. So it's tiny. It's a very, very, very small chance that that our sample mean will be less than 10.7 if we take a sample size of 22. Very, very, very small chance. So now you've seen how to use this this tool to find probabilities of a sampling distribution and also in comparison to a regular probability of a single value.